Hi, in this video I will demonstrate how our tool dBias can be used to tackle biases for the synthetic hiring dataset. This is the visual interface of dBias. We start by selecting the dataset, the label variable, the set of nominal variables, and then in the end we click on causal model. Here at the back end the PC algorithm and structural equation modeling runs to yield us this particular default causal model. Once we have the default causal model, we can refine it by performing a set of operations on different edges. For example, we can select an edge and we can go over here and say direct edge, reverse edge, and different kinds of operations. For the time being, let's say we want to direct this edge. We'll click on this button and we see it gets directed. This green bar here tells us that this modified causal model is a better fit over the underlying data set. Similarly, we can direct other edges and deal with them the way we want to. And in the end, when we have inspected all the edges and dealt with all the undirected edges, we are left with the refined causal model. There are two ways to audit for social biases. One is via the causal network and the other is via the evaluation metrics. Let's say for the causal network, we want to identify gender bias. We can go over here and choose gender and target as job and click on find paths. Here you will find all the paths that connect the sensitive attribute to the label variable. Now it's the job of the user to determine whether these paths are fair or unfair, or if any of the constituting causal edge is unfair. For example, in this case we can see that this direct edge is unfair and this edge is also socially undesirable. The second way is we can go over here and choose gender as the sensitive variable, for example, and let's say choose SVM as the ML model and click on evaluate metrics. Here now we will see a whole bunch of metrics which will help us determine whether there is a gender bias or not as per those different metrics. Here we can see that 15% of females get the job while 26% of males get the job. So we can clearly see a disparity happening here. Moreover, we can also consult parity difference, individual bias, accuracy difference, and all these metrics to see there are significant values going on here as well. So this shows that there is gender bias in this particular data set. To start the debiasing process, we first need to flip this toggle from refine to debias. Now any changes in the causal network will cause generation of the debiased dataset. Next, we want to identify which are the biased causal edges. For example, here we see this as a biased causal edge. We have two options now. Either we can completely remove this edge or we can weaken this edge by, let's say, 25%, 50%, 80% using this slider. Let's say in this particular case we want to get rid of this edge completely. We go over here and say delete edge. When we click this button, at the back end the new data has been generated and these plots have been updated. If you look more closely, you will find that these two plots are different. Here 250 females got the job, over here it's 304. Similarly, here 648 males got the job, here it's 604. So you can already see some kind of balancing act going on. We can further investigate by clicking on evaluate metrics. This will help us understand the impact of this intervention on different metrics. Here we can see that there were 15% females who got the job in the original data set and they have now been increased to 19%. Similarly, the males have come down by 1% and the overall gap, which was 11% here, has now come down to 6%. And it has also caused 2% data distortion, and most of the bias metrics are better or at least kind of same, and utility metrics are also kind of virtually the same basically. So it's good. Next, now we can just stop here and use the current debiased data set, or we can move further and say let's also get rid of this particular undesirable edge. Again, when we delete this edge, at the back end a new data set is generated and we can again visualize its impact by clicking on the evaluate metrics button. Now we see that the gap between males and females has come down to just 1%. although the data distortion has increased to 6%. All of these fairness metrics are showing substantial improvement from where they were, and utility metrics are kind of same again. Lastly, we can go over here and click on debias data to download this debias data set, which we can now use for any downstream application for more fairer predictions. Thanks for watching.